Hello, I'm Nancy Martinez, and today we're going to talk about plate tectonics. Now, 200 to 250 million years ago, scientists have theorized that instead of all the continents being spread out, they were all connected together as one massive supercontinent called Pangaea. Basically, all the continents were pieced together like one massive puzzle until they broke up. There's plenty of evidence to support the theory of Pangaea and the drifting of the tectonic plates. Now, my colleague Kathy Reyes will talk to you about the continental drift theory.
The continental drift theory, brought about by Alfred Wegener in 1912. He was a geophysicist and a meteorologist. Wegener realized when looking at different continents that many of the animals, fossils, plants, and geological structures of the land were similar to those of other continents. Many geologists disagree with Wegener and thought that the Earth's incredible mountains were created because of the planet was cooling and shrinking since its formation. And to account for the identical discoveries on continents such as South America and Africa, scientists invoked ancient land bridges which are now vanished underneath the sea. Of course, they were wrong, and you see the continents do fit like a puzzle, and Wegener was a smart man. And now off to Oliver, who will explain more about the movement of the continents.
As for how the continents move to their current positions, we can thank the intense heat of the Earth's core for that. This intense heat causes molten rock to move in the mantle layer of the Earth, creating what is called a convection cell. It was originally thought that the plates surfed along these convection cells, but over time, scientists began to believe in a new reasoning. This was called ridge pushing, which occurs when hot magma comes up from the mantle and cools, pushing the plates apart from one another. This helped to establish the 12 tectonic plates of the world, and among those are 7 major tectonic plates. All of the names of the major plates are pretty self-explanatory, with the Eurasian, African, Pacific, Indo-Australian, North American, South American, and the Antarctic. Now, these plates especially have issues when interacting with one another. To give a deeper look on those interactions, Laura will talk about boundary issues along with Yaneli.
Hey, I'm Laura Vasquez. There are 3 types of convergent boundaries, such as continental to continental boundaries, continental to oceanic boundaries, and oceanic to oceanic boundaries. Continental to continental boundaries are when neither plate pushes underneath each other, causing a buckle, converge, and compression, which leads to the creation of tall mountains. An example is the Himalayas. Next, we have the continental to oceanic boundary. This boundary issue occurs when an oceanic plate pushes into and moves underneath the continental plate, causing the continental plate to create a mountain range. Lastly, there's the oceanic to oceanic boundary. This is when 2 oceanic boundaries meet and one plate goes underneath the other, creating a deep trench and volcanoes. An example is the Marianas Trench. And now to my colleague Yaneli, who's going to talk about divergent boundaries.
Hello everybody, I'm Yaneli Ruiz. Aside from the convergent boundaries, there are also divergent boundaries. And if you thought the convergent boundaries had issues, you haven't met the divergent ones. There are 2 different divergent boundaries, continental and oceanic. First, let's start off with the continental boundaries. Continental boundaries occur beneath a thick continental plate. The continental plate is arched upwards from the convection currents. They are lifted and fractured into a rift-shaped structure. And as the 2 plates pull apart, normal faults develop on both sides of the rift and the central blocks slide downwards. Now, let's talk about the oceanic boundaries. Oceanic boundaries occur beneath the oceanic lithosphere. The rising convection current below lifts the lithosphere, producing a mid-ocean ridge. Then, extensional forces stretch the lithosphere and produce a deep fissure. When the fissure opens, pressure is reduced on the superheated mantle material below, and it responds by melting, and the new magma flows into the fissure. The magma then solidifies, and the process repeats itself.
Aside from convergent and divergent boundaries, there are transformation boundaries. Well, more like boundary. A transformation boundary are places where plates slide past each other. Since the plates on either side of a transform boundary are merely sliding past each other and not tearing or crunching each other, transform boundaries lack the spectacular features found at convergent and divergent boundaries. Instead, transform boundaries are marked in some places by linear valleys along the boundary where rock has been grounded up by the sliding. An example of a transformation boundary is the San Andreas Fault. And now we are finally done talking about all the boundaries in the world. Moving on.
Oh, hi there. On to more interesting facts. Let's talk about how plate tectonics causes major geological events. First, there are the ocean Basins. Ocean basins are formed from tectonic plates moving apart from one another. The hot magma underneath the plates rises through the cracks and cools when coming in contact with ocean water, creating the basins. Then we have seafloor spreading. Seafloor spreading occurs in mid-ocean ridges. Volcanic activity forms new oceanic crust which moves away from the ridges gradually. Then there are earthquakes. An earthquake is the shaking and vibration of the Earth's crust due to the movement of the Earth's plates. Earthquakes can happen along any type of plate boundary. Earthquakes occur when tension is released from inside the crust. If you thought this was all that caused geological events, wrong. Take it away, Oliver.
Continuing from Kathy's wonderful explanations about geological events, there are two more events that are must-knows. One being volcanic formation, and the other being mountain building. When it comes to volcanic formation, which also includes hotspot volcanoes, this only occurs under the right conditions. The conditions being when plates are pushed together or pulled apart. When this happens, volcanoes are created, which is why they tend to occur in the same place as earthquakes. When tectonic plates spread apart from each other, hot magma rises up and fills the space between. And lastly, we have mountain building. Mountain building is caused by the movement of tectonic plates creating volcanoes around the plate boundaries, which erupt and form mountains. A volcanic arc system is a series of volcanoes that form near a subduction zone, where the crust of a sinking oceanic plate melts. And after all these interesting facts, there's still one more thing you need to know.
The very last yet informational piece you should know about tectonic plates is that all types of plates cause natural events to occur due to the plate's movement. But of course you already knew that, you smart person.
Actually, guys, Laura lied. There's one more thing you need to know. So, what should you eat for breakfast on Earth Day? Pangea cakes. Get it? Pancakes? Pangea cakes? Anyway, hope you enjoyed the Crash Course video. See you next time on Tectonic Plates.